Hi guys, today we'll answer simple yet very important question. What a single machine can handle. Let's go. So what's the context exactly? The context is that we will have one machine and we'll there deploy a single RESTful API written in Java 21, but that is not that important, and it will use Postgres database. We'll have this machine in multiple sizes, as you can see. This is 3 guys. We'll execute tests against those machines, and we'll test how many HTTP requests per second the single machine with our application can handle. So let's go through all steps basically. So as I said, we'll have one simple Java app. We'll use PostgreSQL as a database. We'll have this one table, and we'll have a few realistic endpoints. And those endpoints, they will obviously talk with the database, so we'll get one account by ID, count some accounts by name. Name is not unique, there are multiple accounts for each name, and we also execute some random inserts or deletes so that we have real load as in real application doing our tests. So what we need to have, guys, we'll need to have obviously machine where we deploy our application, and also a few machines to execute our tests, because to load our application more, I decided to run our load tests on 4 machines. So before doing that, let's basically go through things that we have. We have LoadTest, and this is just a tool that I wrote in Java. It will make HTTP requests to our endpoint and print out the results. We can configure it using various environment variables. We'll do this in a while. And but what's important right now is maybe that we have a few test profiles and they have different requests per second rate. We'll also see this in a while, but we'll go with 5, 50, 250 and 1000 requests per second for machines. So we need to multiply this by 4, so the highest we will go is 4000 requests per second. And here we have our endpoints basically. So write account by ID we have here, and count accounts by name. We have also some randomization here. Scripts, we'll use it just in a sec. Single app, as you can see, just single Spring Boot application. We have controller with the endpoints. We also have, I didn't mention that, generate test data endpoint. We generate a little over 1 million rows in our database, so that we also have realistic data in the database. And this controller is using account repository, which is speaking with the database directly. Basically, we have single DB. It's just on Postgres database, nothing fancy here. And yeah, that's mostly it, guys. So let's go through steps, because we have all described here. So we need to prepare infrastructure for the tests. I decided to use DigitalOcean. You can use something else, but then you need to write scripts for that. But for the video, we use DigitalOcean. So we need to have an account there. I do have it. So here we are. And to run our scripts, we need to have a API token from the DigitalOcean, and one more thing. But let's maybe not get too much ahead of ourselves and go through the steps. So first, we need to have Python also. So you need to have it on your machine. And if you have it, just go to the single machine tests directory and let's go. So we should go to scripts. We should set up Python env. So let's do that. Yeah, so we have created the virtual environment basically. Right now we should activate it. Let's activate it. We are in the venv. We have a few dependencies, and we right now need to have this DigitalOcean API key and SSH key fingerprint. We need this to enter our machines using SSH basically. But let's maybe modify those steps a little and just try to run the script without this environment variables. We can't. And we also start with small machine, not the large as we have it. Here we have a mapping basically. Okay, but how we can have this token, guys? If you have DigitalOcean account, you just go to your to panel and API, I believe, and we can generate tokens. So LoadTest, let's say, right? Generated. Obviously, I will remove it after the video, so you can't use it. But let's right now use it. So basically, let's export it and let's run it again. We need to have SSH key fingerprint, and I have prepared one. So you need to do this yourself. But basically, you go to settings, and in security, you can add SSH keys of your machine. So here I have my fingerprint. So I will copy it. I will export as we have it here. Okay, and right now our script should work, and what it will do is it will create a single machine droplet, single machine virtual machine basically. Small, we'll start with these resources. So basically 1 CPU, 2 gigabytes of memory, and it will also create a volume for our database because I want to make it more realistic. We would use external volume to do that. We have also some basic firewall so that nobody is bothering us while we are doing the tests. The firewall is very basic. It basically allows only TCP on port 22, which is for SSH, AT, and 445 for HTTP, and all outbound network also is allowed. And on top of that, we create 4 test machines. We have Ubuntu, and I will skip it, but we also install Docker and set up user so that we can deploy our applications there using Docker. Yeah, so let's run it, guys. Okay, something is happening. We have created a single machine droplet and a few test machines, and we are waiting for them. In the meantime, I believe you can go here and see that our droplets are getting created. Yeah, they are. So basically we need to wait a while. Okay, we are there. Our droplets are active. We're creating volume, attaching it. We should create firewall. Yeah, and we have 5 droplets, guys. Let's see. Right, we have them. So what do we need to do right now? We need to build and package our application. So let's just that. It will build and package the single DB and single app. And for me, it will be quite fast. If you run this for the first time, it can take a while because we use 2 Docker images. That's one. And then we need to have some dependencies for our Java application. So yeah, let's just wait. Okay guys, I have it. I have single app and single DB built. In case you are wondering, all it is in the single app and single DB, you have these directories, and we have just zipped. Here we have zipped Docker images of the application, and we have simple bash scripts that they will load the image from the zip and run them with some parameters, run Docker containers. Yes, so we have our DB, we have our application. Right now we can deploy them. So we have another script for that, which will use SSH to basically transfer those zipped images and then unpack and load them on the machine side. So what we need to do for this, guys, we need to have deploy host. So let's export deploy host. For that we need IP address of our droplet. So let's copy it and let's run deploy apps, I believe. Yeah, and I guess this can also take a while since those images they weigh a few hundred megabytes, I believe. So let's wait again. Okay, single DB was deployed. We have some logs, as you can see. So right now single app is being deployed. So I believe in the meantime we can actually go to the terminal and SSH there. So we have single machine user. We can paste the IP address, and we have access obviously because of the SSH key fingerprint. And as you can see, we have our database. So in the meantime we can enter it. So let's run the PSQL. Let's use a Postgres and let's use our single DB. And we have, yes, we don't have a table because table will be created by our application. But in the meantime it was deployed. We can see some logs from the Spring Boot. So we should have our account table. So let's select something from it. It's empty, obviously. Let's go with next steps, guys. So the next step is to have some data there, because we need to have a realistic scenario as possible for our tests. So for that, what we have is basically, this is less readable. Let's use that. We have an endpoint in our application, as I showed you, and it will create over 1 million random accounts. So let's use cur to call it. We are on our machine. Okay, and let's see how it goes. It will take a while. We need to wait, I believe, something like 30 seconds, maybe 40, 50. So let's wait again, guys. Or yeah, maybe actually, while it is happening, we can deploy our, we can build our load tests. So let's do that. Yeah, let's do that. So basically we are building and packaging our load test, which is just single Java file, also Dockerized, similar to our single app. Okay, we have created our accounts. It took almost 1 minute, so not that quick, guys. So let's maybe go back to our database and see what we have here. So what we have, 1 million rows, over 1 million rows, and some accounts. We can also, maybe if it's that, see, not that, but that, some metadata about our table. Let's maybe see how big it is in terms of megabytes. So I believe the size pretty, get total relation size account, something like that. Yeah, only a few hundred megabytes, even though we have so many rows, guys. Okay, but right now we need to go on with our load tests, guys. So we have built a package for our load tests. So what's next is, we need to deploy them to our test machines. We have 4 test machines, so we need to export test host, but we need to change the IP addresses, obviously. So let's do that. Oh, something went wrong. So let's just write it. And right now we need our 4 IP addresses of our 4 test machines. So let's copy them one by one. 3, 2, and the last one. Okay, we have it, and right now we need to deploy load tests bash. So that's right. And what we are doing right now is deploying our load test zipped Docker image to these 4 machines in parallel. It will also take a while, but we only need to do this once, because the test machines, they will not change. We will reuse them and we'll only change the single machine where our app is located. So let's just wait. Shouldn't take that long, I believe. Maybe 1 minute, maybe 2. Okay, guys, we are almost there. 2 pending deployments. Soon will be 1. And we have it. So right now on 4 machines we have our load test. We don't need to, but we can verify it in a simple way. So let's go to, I don't know, test machine 4. So here we have test machine user. We are there, let's go to deploy, load test, and we have our package, and in the load test, not here, load test results, will have results of our tests. So actually we are now ready to run tests finally. Okay, so how do we run them? We need to export a few more environment variables. So some of them we will reuse, but first is tested host, which is our single machine. So let's paste that. Then what we need is tested machine name only for reports. Here it is large, but remember that we have small machine. We showed why this is important in a while. We need those hosts. It is the same, this host, yes. So that's all basically, guys. Let's run load test. Okay, so as you can see, we have some we have instructions where the output will be, so we can run this in the maybe next terminal. Something is happening. As you can see, stats are up of our machines. CPU is not, it's doing something, it's not idle. Okay, so let's check this, guys. What we have done, we have run the load test, but with low load, as you can see. So we have made only 5 requests per second, 75 requests in total, and here are our stats. So as you can see, it's quite fast, extremely fast, to be honest. 99.9th percentile, under or almost under 100 milliseconds. So our machines basically are bored with that. So let's do the test with more load. So what you can do is we have test profiles, as I said. So the default is low load, so 5 requests per second on 4 machines, which is 20 requests per second for 15 seconds. So that's why 75, 5 times 15. And so let's do not low load, but the average load. It will be slightly higher. And let's run it. Okay, right now I believe we just need to change the file name slightly. And let's see that CPU is much more busy right now. Remember that we have one CPU, so combined we takes more resources actually right now. But as you can see, the times are still very good. So still 99th percentile is very low. So let's run the average load, but high load. That will be significantly more requests. If I remember correctly, it will be 250 requests on one machine, 4 machines, so 1000 requests per second. So let's see. Oh, we got some timeouts, as you can see. CPU is very high, one CPU that we have. And yeah, so basically 52% of requests ended up with timeouts, and we have pretty high timeouts, as you can see, 5 seconds. So yeah, Let's maybe run it again, but I would say that this machine basically can't handle 1000 requests per second. But as we repeat, a few hundred requests per second were doable for it. Okay. Yeah, high load. Okay. Yeah, so as you can see, for the second time it handled it pretty well. So something was wrong, guys. So we can do this. I guess we have shared CPU, so that might be the case. So if we can handle it, let's maybe run it to be sure. But even if we can, as you can see, the CPU is very loaded, so we are on the verge of running out of resources basically. So even if it works, it is really temporary. Yeah, so turned out that we can do this basically. On this small machine we can handle 1000 requests. So let's go with something that shouldn't really be handled by this small machine. Very high load, which means that from each machine we will do 1000 requests per second, so 4000 in total. So let's see. CPU is similar, so close to 100%. Okay, timeouts. Let's wait. Still not finished. Yes, so right now lots of timeouts. Median is 5 seconds. Average is also around 5 seconds. But as previously, let's rerun it to be sure. Okay, we are starting it out. I think that should be the limit basically of this small machine. Yeah, so timeouts again. Let's wait. Yeah, so very similar. It's better, but still not acceptable. We shoot for less than 2 seconds, or 99%, I would say. Okay, guys, so that's the limit. I will sum up in the end, but basically that's the limit of our small machine. It can handle high load, basically, temporarily, I would say, because you saw how CPU was how it was loaded. But high load for us, it means around 1000 requests per second. It handled it pretty well. So let's go with the bigger machine. So what we'll do right now is we'll kill this. We'll destroy this single machine, basically. Let's destroy it. Okay, and we will basically, guys, prepare infra again, but not with small machine, but medium. And it is idempotent, as you can see. We only need to create a single machine. Test machines are ready. So let's wait a while. Should be visible here already. Let's see. Yeah, it is getting created, and previously we had 2 gigabytes of RAM and 1 CPU. Now we have 4 gigabytes of RAM and 2 CPUs. That's the difference. And after that, we'll also try this with 80 gigabytes of RAM and 4 CPUs with dedicated. And it will be dedicated because the machines that we are using here, they have shared CPU. That's why probably we had this strange performance difference, because it is shared. So we don't have performance guarantees. Okay. So we have our machine, and we need to repeat some of the previous steps. So we have packaged our DB and app, so we don't need to do this again, but we need to deploy them again. So let's change the deploy host, because we have different IP address right now, and let's deploy our apps there to different hosts. Oh, permission denied. This means basically that our preparation script hasn't finished running. I didn't show you that, but on start of the initialization of the machine, we are running this script which set up the user that we are using, this placeholder, which is changed in the prepare infra by. We are basically setting up SSH and installing Docker. So this is what is happening right now. Let's retry. Yeah, right now it works. So basically we need to wait again to copy the database package and single app package. Fortunately, we have our load tests on 4 machines, so we will not need to do that. We will just need to initialize our database. So let's wait. Okay. And yeah, so Docker was not ready. So let's run it, and as it is running, we can go to our terminal and check whether we can go there. We can. And yes, the Docker is ready. It wasn't before, so we were too soon at that stage. So let's wait, guys. Okay, single app is also finishing its deploy. So it should be running this. Oh, it's a nice CPU pick, by the way. Alright, guys, so let's initialize the database. As you might recall, we just need to use our endpoint, which is that. So let's do this. Okay, and we need to wait for the database to finish initializing. We can also compare, see how many CPUs does it take. Yeah, so DB is quite busy doing this insert, but right now we also have 2 CPUs, so this close to 80 or 90% CPU usage. We have 200 CPUs, 200% available. Keep that in mind, because we have 2 CPUs. Okay, let's see. Mostly done. Yeah, it took a few seconds less. So we can actually almost run our test. So let's change a few variables. So tested machine is medium, and tested host, I believe it was. Let's check. Tested host. We need to change that to our new IP address. Let's change it. Okay, and before we will run our tests, if we go to test machine 4, doesn't matter, test results, we have results, and thanks to this naming convention, we're able to compare the results basically. Okay, so let's also change the test profile because we have high load. Let's just run it with low load again to warm up our machine. So bash run load test. Let's see. Should start. Yeah, it's starting. We can read it from this machine directly this time. So medium low load. Okay, as previously, very fast. Low load. We don't need to even analyze the low load. Let's just go straight to high load. See what we have here. Yeah, so busy CPU, busy. We have 200%, remember that. Let's see the times. Yeah, so worse, but remember that there is a warm-up factor. So let's run them again, and I'm sure they will be better. Okay, running. Yeah, as you can see, significantly better. Yeah, but it's like nothing, basically. 99.9, I don't know if I say this correctly, percentile below 72 milliseconds. No timeouts. This is 1000 requests per second basically. So let's go with very high load, which is 4000 requests per second. Okay, CPU busy. So very high load, we should have something. Oh, some timeouts, but we should have less than previously. So previously, as you may remember, the median and average was about 5 seconds, so we didn't handle it at all. Here, as you can see, it is already better. Mean is, which is average, 2.5 seconds, percentile, median and average, and 5 seconds is on 19th percentile. We have some timeouts, but significantly less. Let's run it again as previously. And in the meantime, let's check out again the small machine. Results, yeah, median and mean are around 5 seconds and lots of timeouts, as you can see, over 50% of timeouts. So we do have timeouts with medium machine, but less, significantly less. No read timeouts, some connect timeouts, and yeah, mean significantly better. Percentile 75th percentile is 4 seconds. Previously it was 5 and 5 for median. So yeah, significantly better, but we still can't handle 4000 requests, but we can handle 1000 requests without any problems. So that's for medium machine, guys. So for the last time, we destroy this machine, and we try large machine. So let's destroy it. let's destroy this droplet so they don't charge us all of this money. Okay, and again we had our glorious prepare infra script, not medium this time, but large. So right now the difference is that not only we have more resources, 4 CPUs and 8 GB of RAM, but also the CPU will be dedicated, not shared. So this is slightly, also because of that, it is slightly more expensive, but obviously interesting to check out. Okay, so our machine is getting created. Let's wait. Okay guys, so we have our machine. Script has finished, but here we still don't have an IP address, so probably we need to wait a few seconds, but let's try it anyways. So export deploy host. Let's actually check that we can SSH there. Okay, again, Docker is working, so let's deploy our apps as previously. Permission denied. Yeah, okay, here we also had this, I just ignore it, so let's wait. Okay, now it works. So let's deploy our DB and app as previously for the last final time. Okay guys, we have it. Single app is starting. Let's see that it works. Waiting for its logs. Yeah, it works. So as previously, we basically need to, okay, let's SSH again. We need to basically initialize our database. So let's do this. Let's check logs of our single app. Yes, so we are initializing the database. It will take a while, but it is for the last time. We have our final results. How about the load, guys? So similar to previously, close to 100% during database initialization, but we do have 4 CPUs actually. In the meantime, we can check out the metrics from the DigitalOcean, and it also makes sense, 20%, because we were close to 100, but we have 4 CPUs, so if 100 it would be 25, but it was a little less. Yeah, you could let's ignore this for now. So it means that we have took less, so 40, and we can, guys, run our tests again. So again, we need to change tested hosts, and what else we had? Machine name to large, so that we have separate files for results. And let's, as previously, start with LoadTest profile, and let's run our tests. Basically, let's show stats. Okay, they're running. Let's see. Large low load. Okay, it's nothing as previously. Let's do with high load. Okay, let's see CPU usage. We are using more CPUs than previously because we can. Alright, again, very nice times. 99th percentile below 75 milliseconds, but let's run it once more because warm up factor. Yeah, but interestingly, less CPUs right now are getting used. Okay, significantly better as you can see, so no issues there. So as previously, our final test profile, very high load. Let's check this one, guys. So 4,000 requests per second, basically. Okay, no timeouts. Interesting. Okay, so as you can see, significantly better. Mean is below 1/2 second, so that's amazing for 4,000 requests. But let's run it again and only then compare the results. Let's check the CPUs. Yeah, it is a lot, but the times are amazing. No timeouts. Yeah, so as you can see, even better. We didn't, the max is 1 second. So that's amazing, guys. So to compare the very high load, maybe we started with small machine and it failed at that. So small machine wasn't able to handle very high load, which is 4,000 requests per second. It was able to handle high load pretty nicely, which is 1,000 requests per second. With medium machine, we had better times with high load, but we failed at very high load. I mean, we almost handled it, but it was pretty slow. We had some timeouts, and with large machine, we are able, large machine being 4 CPUs and 8 GB of RAM, we are able to handle 4,000 requests per second without any problems. So that's all I think, guys. Check out the repo, play with it, tinker with it, tell me what you think, and if you like the video, subscribe to the channel, and I see you in the next one. See ya!